China and Russia collaborate on lunar nuclear power plant for International Lunar Research Station ILRS. Date, April 24, 2025. Location, Shanghai, China. Overview. In a significant development for lunar exploration and international collaboration in space, China and Russia are moving forward with plans to establish a nuclear power plant on the Moon. This initiative aimed at supporting the International Lunar Research Station ILRS was announced by a senior Chinese official at a conference in Shanghai. The plans reflect China's aspirations to solidify its status as a leading spacepower with a goal of landing astronauts on the Moon by 2030. Key developments. 1. Chang'e 8 Mission 2028. The upcoming Chang'e 8 mission scheduled for 2028 is pivotal for laying the groundwork for a permanent manned lunar base. Chief Engineer Pei Xiaoyu highlighted that energy for the lunar base could be generated through a combination of nuclear power and large-scale solar arrays, along with essential infrastructure for heating and electricity on the lunar surface. 2. Nuclear reactor plans by 2035. Russia's space agency Roscosmos has previously indicated its intention to construct a nuclear reactor on the Moon by 2035 in partnership with the China National Space Administration (CNSA). This aligns with China's vision of establishing a robust lunar outpost, particularly focusing on the Moon's South Pole region. 3. International Lunar Research Station ILRS. The ILRS is expected to be developed in phases with a basic model slated for completion by 2035. China aims to expand its collaborative efforts globally, inviting participation from 50 countries, 500 research institutions, and 5,000 researchers under its ambitious 555 project. 4. Geopolitical context. This collaboration has gained momentum, especially in light of increased cooperation between China and Russia following geopolitical tensions, particularly after Russia's invasion of Ukraine. Analysts suggest that technological advancements from China could bolster Russia's space ambitions, especially as Western sanctions limit access to certain space technologies. Nuclear power feasibility and strategic implications. The potential of nuclear power as a sustainable energy source for lunar operations has been emphasized across multiple reports. Russia's expertise in nuclear technology is viewed as a significant advantage for the development of the lunar power plant. The collaboration not only highlights the technological capabilities of both nations but also serves as a strategic partnership amidst competition in the global space arena, particularly against the backdrop of U.S. efforts in space exploration. Presentation highlights. During the conference, Wu Weiren, chief designer of China's lunar exploration program, underscored the importance of power supply for the ILRS, noting Russia's advanced position in nuclear power technology, particularly for aerospace applications. He expressed optimism about the potential for both countries to successfully deploy a nuclear reactor to the Moon. Timeline and future prospects. China's timeline for establishing a lunar outpost aligns closely with NASA's Artemis program, which aims to return U.S. astronauts to the Moon by December 2025. The ILRS project presents a counterpoint to these ambitions, with China and Russia's collaborative efforts potentially reshaping the landscape of lunar exploration. The ILRS is expected to prioritize resource utilization on the Moon, including the exploration of mineral and water resources, with plans to potentially use lunar materials as fuel. This focus on sustainability and resource management is becoming increasingly relevant as both nations look to establish a long-term human presence on the Moon. Conclusion. The collaboration between China and Russia to build a nuclear power plant on the Moon marks a significant milestone in their joint lunar ambitions and the future of international space exploration. With the ILRS project poised to redefine the parameters of lunar research, the integration of nuclear energy will play a crucial role in supporting sustained human presence on the Moon, as both nations continue to advance their capabilities. This partnership may redefine the dynamics of lunar exploration in the decades to come. Related sources. 1. Reuters, China-led lunar base to include nuclear power plant on moon's surface at www.reuters.com/business/energy/ China-led lunar base include nuclear power plant moon's surface space official 2025-04-23/. 2. India Today, China-Russia planning to build nuclear plant on the moon www.indiatoday.in/science/story/ China-Russia planning to build nuclear plant on the moon to power lunar station 2713831-2025-04-24. 3. Yahoo News, China-led lunar nuclear power initiative www.yahoo.com/news/ China-led lunar nuclear power 0708292237.html. The information provided highlights a fascinating collaboration between China and Russia regarding space exploration, particularly their plans to construct a nuclear power plant on the moon to support the International Lunar Research Station ILRS. Several counterintuitive aspects emerge from this collaboration, challenging common perceptions about international space efforts and geopolitical dynamics. 1. Collaboration over competition. It is often assumed that space exploration is a domain where competition, particularly between superpowers like the US, China, and Russia, prevails. However, this initiative illustrates a significant shift toward collaboration. Despite their historical rivalries and ongoing tensions exemplified by Russia's invasion of Ukraine, the two nations are choosing to partner in a high-stakes arena. This suggests a more nuanced understanding of international relations where pragmatic cooperation can occur even amid geopolitical strife. 2. Nuclear energy as a preferred solution. The idea of using nuclear energy to power lunar operations might seem counterintuitive, especially given the prevalent public concerns about nuclear power on Earth. Many might assume that solar energy would be the obvious choice, particularly in a setting like the moon, which receives continuous sunlight in certain areas. However, the decision to consider nuclear power stems from its ability to provide a consistent and robust energy supply, which is vital for long-term lunar habitation. This reflects a pragmatic approach to energy needs in extreme environments where solar energy might not suffice due to local conditions. 3. Geopolitical dynamics shaping space exploration. The collaboration is framed as a response to Western sanctions on Russia, particularly following its actions in Ukraine. This creates a scenario where China, often seen as a competitor to the US in space, is positioning itself as a crucial ally to Russia. The counterintuitive aspect lies in the fact that the space race, typically viewed through a lens of national pride and competition, is now being influenced by international sanctions and political pressures. Thus, economic factors are reshaping the landscape of global space exploration. For China's role as a support system, while China has been positioning itself as a leading space power through its own ambitious programs, its willingness to assist Russia in overcoming technological constraints is unexpected. This could be viewed as an inversion of roles. Traditionally, Russia has been the leader in space technology, and now it finds itself in a position where it needs to rely on China's advancements. This shift indicates a potential realignment of power in the realm of space technology, with China emerging as a crucial player capable of supporting other nations. 5. Public perception of space collaboration. The collaboration between China and Russia may provoke skepticism among Western observers who might see it as a threat due to the nation's authoritarian regimes and military ambitions. However, this partnership could also signal an era of more inclusive global cooperation in space exploration, where countries unite to tackle shared challenges such as sustaining human life on the moon. The counterintuitive element here is the potential for positive outcomes in international relations through collaborative efforts in a domain traditionally marked by competition and conflict. 6. The broader implications for global space governance. The ILRS project, which aims to involve numerous countries and research institutions, raises questions about governance and collaboration in space. It challenges the notion that space exploration is solely for national pride or military advantage. Instead, it highlights an emerging framework where international cooperation could lead to shared benefit scientific advancements. and a more peaceful exploration of outer space. This represents a significant shift from competition-driven narratives to those emphasizing mutual benefit and collaboration. 7. Long-term vision versus immediate goals. The timeline set by China and Russia aiming for a lunar base by 2035 in conjunction with the 2028 Chang'e 8 mission reveals a long-term vision that contrasts with the often short-term thinking seen in political arenas. This counterintuitive focus on long-term goals in an environment driven by immediate political concerns suggests that space exploration may transcend typical geopolitical conflicts and foster a shared human endeavor where the benefits of collaboration outweigh the incentives for competition. In conclusion, the collaboration between China and Russia in building a nuclear power plant on the Moon reveals several counterintuitive dynamics within international space exploration. It highlights a shift from competition to cooperation, underscores the pragmatic choice of nuclear energy over solar power, and reflects changing geopolitical landscapes influenced by sanctions and technological dependencies. As these nations forge ahead with their ambitious plans, the implications for global space governance, international relations, and the future of human presence beyond Earth are profound and warrant close observation. The collaboration between China and Russia to build a nuclear power plant on the Moon is a pivotal development in the realm of international space exploration and geopolitical dynamics that is likely to be overlooked in various discussions surrounding the topic. While much attention is often given to the technical aspects and the ambitious timelines of lunar missions, several underlying factors and implications merit a deeper examination. 1. Nuclear power as a game changer. The significance of nuclear power for sustained lunar operations cannot be overstated. Traditional solar power systems, while effective, are limited by the Moon's day-night cycle, which lasts about 29.5 Earth days. This limitation necessitates a reliable and continuous power source for any long-term lunar presence. Nuclear power offers a solution with its potential for high energy output and durability. Moreover, the Moon's south pole is believed to house water ice which could be converted into hydrogen and oxygen for fuel, thus enhancing the feasibility of nuclear power operations. The integration of nuclear technology in space exploration is not just about energy supply, it represents a critical advancement in engineering and safety protocols that could influence future missions to Mars and beyond. 2. Geopolitical implications of space collaboration. The collaboration between China and Russia is a strategic maneuver that reflects their growing partnership in the face of Western sanctions and geopolitical pressures. The backdrop of increased cooperation following Russia's invasion of Ukraine emphasizes a shift in global alliances, particularly in high-stakes domains like space exploration. Analysts note that this collaboration could potentially serve as a counterbalance to U.S. efforts and initiatives such as NASA's Artemis program. By jointly developing lunar infrastructure, China and Russia may seek to establish themselves as the leading powers in lunar exploration and, by extension, in space technology as a whole. This could have far-reaching implications for international space law, resource allocation on celestial bodies, and the establishment of lunar governance frameworks. 3. The role of international collaboration. The ambitious 555 project, which aims to involve 50 countries and 5,000 researchers in the ILRS initiative, is a significant aspect that often goes unnoticed. This project signals China's intention to position itself as a leader in global scientific collaboration. By inviting participation from numerous countries, China is not only sharing the burden of lunar exploration but also seeking to cultivate a sense of ownership and commitment among international partners. This collaborative approach could foster a more inclusive environment for scientific research and exploration, contrasting with the more unilateral approach seen in some Western-led initiatives. However, it also raises questions about the motivations behind such inclusivity. Are these efforts genuinely aimed at advancing global scientific knowledge, or are they strategically designed to bolster China's geopolitical influence? 4. Technological advancements and their implications. Technologically, the advancement of nuclear reactor design specifically for lunar application is a complex and significant challenge. Russia's expertise in nuclear technology combined with China's rapid advancements in space engineering could lead to breakthroughs that might have implications beyond the moon. The development of small modular nuclear reactors for space could significantly alter the landscape of energy production for future space missions. Additionally, the technologies developed for the ILRS could have dual-use applications leading to advancements in energy systems on Earth. The cross-pollination of technologies between space exploration and terrestrial applications is often overlooked but holds potential for significant benefits in addressing energy challenges on our planet. 5. Potential for resource conflicts. The Moon is rich in resources including rare minerals and helium-3, which is considered a potential fuel for future fusion reactors. As China and Russia establish a foothold on the Moon, the potential for conflicts over resource exploitation could escalate. The lack of clear regulatory frameworks governing lunar resources poses a risk of competition and conflict reminiscent of historical territorial disputes on Earth. The investigation of lunar resources, as mentioned in the reports, could lead to contentious claims and geopolitical tensions, particularly if other nations perceive these actions as encroachments on shared celestial resources. As nations look to the Moon not just for exploration but as a source of valuable materials, the implications of these activities will need careful monitoring and international discourse. 6. Public perception and ethical considerations. Public perception of nuclear technology is often fraught with concerns regarding safety and environmental impact. While space agencies are likely to prioritize safety in their nuclear endeavors, the introduction of nuclear power in space exploration could evoke fears reminiscent of terrestrial nuclear issues. How these projects are communicated to the public will be critical in shaping acceptance and support for lunar nuclear power initiatives. Furthermore, ethical considerations surrounding the militarization of space and the potential for nuclear technology to be weaponized cannot be ignored. As nations develop capabilities to launch nuclear reactors into space, the risk of dual-use technologies becoming tools for military advantage could raise alarm among global citizens and policymakers alike. Conclusion. The proposed collaboration between China and Russia to build a nuclear power plant on the Moon is not merely a technical endeavor. It encapsulates a complex interplay of energy needs, geopolitical strategy, technological advancement, and ethical considerations. While the technical details and timelines of lunar missions often dominate discussions, understanding the broader implications of this partnership is essential for comprehensively grasping the future of space exploration and international relations. As these nations pursue their lunar ambitions, the outcomes will likely reverberate through the fabric of global governance, scientific collaboration, and the quest for extraterrestrial resources. Here are the 4 most valuable points for in-depth analysis and discussion regarding the collaboration between China and Russia to build a nuclear power plant on the Moon. Aimed at supporting the International Lunar Research Station (ILRS). 1. Technological synergy and feasibility of nuclear power in space exploration. The partnership between China and Russia highlights the feasibility and strategic advantages of utilizing nuclear power for lunar operations. Historically, nuclear technology offers a more stable and continuous energy source compared to solar power, especially in the Moon's environment where solar energy can be intermittent due to prolonged periods of darkness. The involvement of Russia's expertise in nuclear technology is particularly significant, as their advancements can facilitate the construction and deployment of a nuclear reactor on the Moon. This collaboration not only provides a solution for energy supply but also showcases the technological capabilities both nations possess. The potential for nuclear power to enable sustained human presence on the Moon opens up discussions regarding the long-term viability of lunar bases and further space exploration. 2. Geopolitical implications and strategic alliances. The collaboration between China and Russia comes amidst significant geopolitical tensions and changing dynamics in global power structures, particularly following Russia's invasion of Ukraine. This partnership can be viewed as a counterbalance to Western space initiatives. particularly those led by the United States through NASA's Artemis program. The strengthening ties between China and Russia signal a strategic alliance that extends beyond mere space exploration. It reflects their shared interests in countering Western influence and fostering a multipolar world order. The ILRS project, with its ambitious scope, invites participation from multiple countries, indicating a strategic shift in international collaborations in space. The geopolitical implications of such collaborations warrant a deeper analysis of how they might reshape global governance in space exploration and international relations. 3. International collaboration and the 555 Project. China's initiative to include 50 countries, 500 research institutions, and 5,000 researchers in the ILRS under the 555 Project emphasizes a commitment to international collaboration in space exploration. This approach could foster global partnerships and knowledge sharing, potentially leading to advancements in various scientific fields related to lunar research. However, the motivations behind this push for inclusivity may also be scrutinized, as it could serve to legitimize the China-Russia partnership while simultaneously framing their joint efforts as a global initiative rather than a bilateral endeavor. Discussions around the ethical implications of such collaborations, including equity and access to technology and research benefits, will be crucial as the project progresses. 4. Future of lunar exploration and space policy. The construction of a nuclear plant on the Moon signifies a pivotal moment in the future of lunar exploration. As both China and Russia aim to establish a sustainable human presence on the Moon, the implications for space policy and international regulations become increasingly pertinent. The ILRS project raises questions regarding the governance of lunar activities, particularly in terms of resource utilization, environmental concerns, and the militarization of space. As nations pursue their lunar ambitions, there is a pressing need for a cohesive international framework to ensure that lunar exploration benefits all of humanity rather than being dominated by a few powerful nations. Analyses of potential regulatory frameworks, environmental impacts, and the ethical responsibilities of spacefaring nations will be essential as the ILRS and similar initiatives develop. Conclusion. The collaboration between China and Russia in building a nuclear power plant on the Moon encapsulates significant technological, geopolitical, and ethical dimensions that warrant thorough exploration. As both nations advance their lunar ambitions, it is crucial to consider the broader implications of their partnership for international space exploration, governance, and cooperation among nations. The evolving dynamics of space policy will play a central role in shaping the future of humanity's endeavors beyond Earth. 1. The Manhattan Project, 1942 to 1946. This was a secret U.S. government project during World War II aimed at developing the first nuclear weapons. The project brought together some of the greatest scientific minds of the time, including J. Robert Oppenheimer and Enrico Fermi, to harness nuclear fission for military purposes. The culmination of the Manhattan Project was the development of 2 atomic bombs, which were dropped on Hiroshima and Nagasaki in August 1945, leading to Japan's surrender and the end of the war. The project not only marked a significant technological achievement but also raised ethical and geopolitical concerns regarding nuclear weapons that resonate in discussions about nuclear power and international cooperation. 2. The Apollo Program, 1961 to 1972. This U.S. space program was designed to land humans on the Moon and bring them safely back to Earth. It was initiated in the context of the Cold War and the space race with the Soviet Union. The program culminated in the successful Apollo 11 mission in July 1969, during which astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the lunar surface. The Apollo program involved significant international collaboration in science and technology, influencing future space exploration initiatives and establishing the United States as a leader in space technology. 3. The International Space Station, 1998-present. The ISS is a multinational collaborative project involving 5 participating space agencies: NASA United States, Roscosmos Russia, JAXA Japan, ESA European Space Agency, and CSA Canada. It serves as a microgravity and space environment research laboratory where scientific research is conducted in astrobiology, astronomy, meteorology, and other fields. The ISS has been instrumental in fostering international cooperation in space exploration, showcasing how collaborative efforts can lead to significant advancements in technology and research, much like the proposed lunar station. The station's continuous human presence in low Earth orbit for over 2 decades has also provided insights into long-term human spaceflight, which is vital for future lunar and Martian endeavors. The collaboration between China and Russia to build a nuclear power plant on the Moon represents a pivotal moment in space exploration and international relations. This initiative aims to support the International Lunar Research Station (ILRS) and reflects both nations' ambitions to establish a significant presence in lunar operations by the mid-21st century. Here are some predictions for the future based on current trends and the developments outlined in the recent reports. 1. Technological advancements in space exploration. As China and Russia push ahead with their lunar plans, we can expect significant technological advancements in space exploration. The successful deployment of a nuclear power plant on the Moon could pave the way for more sustainable and long-term human presence on celestial bodies. This technology may not only enhance lunar operations but could also be adapted for potential missions to Mars and beyond. Innovations in power generation, resource utilization, and life support systems will likely emerge as both countries share their expertise and resources. 2. Increased international collaboration. The 555 project proposed by China aims to involve 50 countries, 500 research institutions, and 5,000 international researchers in the ILRS initiative. This model of international collaboration could set a precedent for future space missions, fostering a more cooperative approach to exploring and utilizing space resources. As countries recognize the benefits of joint ventures in space exploration, we may see a shift away from nationalistic endeavors toward more collaborative, multinational projects. 3. Geopolitical dynamics in space race. The geopolitical landscape will continue to evolve, particularly as China and Russia strengthen their ties in response to Western sanctions and pressures. The Moon will become a new arena for geopolitical competition where technological supremacy and resource acquisition will play crucial roles. The collaboration between these two nations may prompt other countries, particularly in the West, to accelerate their own lunar and space exploration programs, leading to a renewed space race reminiscent of the Cold War era. 4. Sustainability and resource management. The establishment of a lunar base powered by nuclear energy will likely focus on sustainable practices with an emphasis on in-situ resource utilization (ISRU). This includes using lunar materials for fuel and construction, which could significantly reduce the need for supplies from Earth. As technology advances, the Moon may serve as a testing ground for sustainable practices that can be applied to Earth, addressing issues such as energy supply and resource management. 5. Impact on global space policy. The developments surrounding the ILRS and lunar nuclear power may catalyze changes in global space policy. As the Moon becomes a site of international interest and potential resource exploitation, discussions around space governance treaties and regulations will become increasingly vital. Countries will need to navigate the complexities of sovereignty, resource rights, and environmental considerations on the Moon, leading to potential new frameworks for international space law. 6. Commercial opportunities in space. The collaboration between China and Russia may also stimulate commercial interest in lunar exploration. Private companies could emerge to support infrastructure development, resource extraction, and technology transfer, creating a new space economy. As governments invest in lunar projects, partnerships with the private sector will likely become essential for scaling operations and innovation. 7. Public interest in space tourism. As lunar exploration becomes more feasible, public interest in space travel will likely surge. The prospect of a human presence on the Moon could inspire a new generation of scientists, engineers, and space enthusiasts. Additionally, the development of lunar tourism could become a reality, with private companies offering trips to lunar bases or orbital hotels, further integrating space travel into mainstream culture. 8. Exploration beyond the Moon. With a successful lunar base, attention will inevitably turn to Mars and beyond. The technologies developed for the ILRS and the Moon's nuclear infrastructure could serve as a foundation for future interplanetary exploration. As China and Russia make strides in lunar operations, they may also set their sights on Mars, fostering competition and collaboration in the quest to explore the solar system. Conclusion: the collaboration between China and Russia to build a nuclear power plant on the Moon signifies a transformative period in space exploration and international relations. As both nations pursue their lunar ambitions, the implications will extend beyond technological advancements to influence geopolitical dynamics, international collaboration, sustainability practices, and the future of space policy. The next few decades will be crucial in shaping humanity's presence in space and determining how nations navigate the challenges and opportunities that arise from this new frontier.